This is Chapter 3, Lesson 1, and today we're going to talk about solving systems, and we're going to specifically talk about how to solve them using a method called elimination. In another video, you'll learn how to solve the equations by substitution and then by graphing and so on. One thing that you need to know is what a system is. A system is just when you have two or more equations that are working together. In this case, we're talking about linear equations, so you've got more than one, and you need to solve, in this case, we're talking about lines that intersect or maybe lines that are parallel, and we want to find out what is the solution that is for both, like what solution works, what point is on both lines. So the first thing that you want to do is make sure that you have your equations in standard form, ax plus by equals c. And then you're going to try to eliminate a variable. So when you eliminate, you try to make the same value, but they're opposite. So you have one positive and one negative, so that when you combine them together, it will cancel. So let's just start with one. This first one here. Let's put it in standard form first. Because the x and the y terms are already on the side that they need to be on, I just need to swap places. So we can use the commutative property to do that. We do not have to change the sign on anything because I'm not moving over the equal. So 3x just needs to be placed in front, and then plus y equals negative 2. I just rewrote this problem in standard form. In this one, we have negative 3x plus 2y equals 14. Now the key here is to write them directly below each other, like in line them up, so that your x's are lined up, your y's are lined up, and then your constants are lined up on the other side. Draw a line up under them as if you were going to add them together. And if you notice 3x and negative 3x, if I add them together, 3 plus a negative 3 is going to make 0. Not 0x, just 0. So nothing will be left there. Those are gone. The y here is understood to have a 1 in front, so we have 1y plus 2y's. So there are a total of 3 y's in this column. Equal sign. Then we have a negative 2 and a 14. So negative 2 and 14 makes 12. Now we have a simpler equation that we can work with. Divide by 3 here. We want to solve for y. Y equals 4. Now plug back in the 4 to one of your original equations. It doesn't matter which one, as long as you use the y value now as 4. I'm going to use this first one, so I'm going to say 4 plus 3x equals negative 2. 4 again was my y value, plus 3x equals negative 2. Solve for x now. Minus 4 minus 4. 3x equals a negative 6, and divide by 3, x will equal negative 2. Your goal is to find a value for your x and your y. Now, sometimes your equations aren't going to be already ready to cancel, so sometimes you may have to make them work. If you look at these two, they're already in standard form, and I can cancel whatever variable I'd like to. I can cancel the x's if I want to, but I'd have to change and make them a common value. Here I have a 3y, and I've got another 3y, so that's going to be an easy change because they already have the same value of 3. I just need to make one of them negative. So pick one, it doesn't matter, and make it negative. I'm going to choose this one, and I'm going to multiply everything in this equation by negative 1. So I'm going to have 2x minus 3y equals a positive 5. Then I'm going to rewrite the first equation, 3x plus 3y equals 15. Now, when I combine these together, the y's are going to cancel now because I have a positive 3y. And when I put that with a negative 3y, it makes 0. So that's gone. Everything else should generate values. So 3x plus 2x is 5x's equals 15 with 5. 15 plus a 5 is 20. And so divide to find x. X equals 4. Plug back in your 4. Some students stop here. Don't stop here. You've got to get the y value too. Plug back in the 4. I'm going to use the first equation. So I have 3 times x, which I found to be 4, plus 3y equals 15. 12 plus 3y equals 15. Take the 12 to the other side. 3y equals 3, and therefore y equals 1. Okay, so that was another step forward because we had to make this one a negative, so you just had to multiply everything by -1. Anytime you multiply the entire equation by a value, it keeps it balanced, so you're making something that is equivalent. Okay, let's look here. Well, if you notice, it's already in standard form. They're both set up, the x and then the y and then the constant. But 3, and this is -1. 2, and this is 1. But what we need is a common value. So just choose one of them. I like the fact that this is already negative, and if I want to cancel out my x's, really all I have to do is get a 3 here. Understanding that this is a 1, I can multiply the entire equation by a 3 to make this become the 3x, and in this case it will be -3x. So I'll have -3x plus 3y equals, and don't forget 3 also gets multiplied by -2, so -6. Then I rewrite the top, so I have 3x plus 2y equals 6. The x values are opposites, they cancel out. Then I have 5y equals 6, and -6 makes 0. It is okay for you to have a value of 0. Keep dividing or keep solving. So y is going to equal 0 because 0 divided by 5 is 0. Now this is easy to work with because now when we plug in 0 for our y, it should be easy. So I'm going to go back to the first, it doesn't matter, either equation. Plug in y equals 0, so 3x, I'll do the first one, plus 2 times 0 equals 6. Well, 2 times 0 is just 0. 3x equals 6, and so x will equal 2. Okay, and then the last one here. In this case, you look at the 2 and the 3, and I know I could make them into 6, and one's already positive and one's negative. I'm looking for a common multiple that I can use. So I know that 2 times 3 would make 6, and 3 times 2 would make 6, so that's okay. I could do that. 5 and 4, a common multiple would be 20. I can make both of them turn into 20 by multiplying by, in this case 4, and in this case 5. So you want to pick the one that you want to work with. I'm going to choose 6 because it's smaller values to work with. And so I'm going to have to multiply this whole equation here by 3 and this entire equation here by 2. So I'm going to get 6x plus 15y equals, and 3, 18, 6, 7, 78. And here I'm going to do -6x plus 8y equals -50. The 6x and the negative 6x, when combined, they cancel. They make 0. 15 and 8 makes 23 y's. And then here we have 28. As long as I've done everything correctly. Okay? If I divide by 23, divide by 23, I should have picked a value that works nicer than this. We can change this, but it's okay for now. So y equals 28 over 23. Okay, take the y value and plug it back into one of these y values. It's not going to be pretty. So what we're going to do is, let's work with the first equation. 2x plus 5 times the y value here, 28 over 23, equals 26. Now remember, 5 is just 5 over 1, and when we multiply, we do the numerators and then the denominators together. So we'll have 2x equal, plus, I know we get 40, 4s, 10, 14, 140 over 23 equals 26. Subtract 140 over 23 from both sides. Now what I'm going to do here is I'm going to use the calculator. So I am going to type in I'm going to type in 26 minus, and I'm going to do the calculator trick that some of you already know. I'm going to do the calculator trick. So you do alpha y equals. This will give you the numerator and denominator. And I want it to subtract 140 over 23. And I'm going to press enter. That's my fraction there. So this canceled out. I got 2x equals that fraction. 2x equals, and I'm sorry for giving you such a horrible problem here, 458 over 23. Divide this by 2. Divide by 2. If we take our answer here and divide by 2, all I did was hit divide and it popped up take your answer and divide by 2. And we get 229 over 23. So x equals 229 over 23. Your problems should not be that terrible. I think I just messed up on a sign where we should have had a 7 here. If we would have had a 7 here, we would have divided perfectly. So, okay, that's all for this video. If you have any questions, please make sure you let me know.